Today we're diving into an idea that pretty much flips our whole understanding of intelligence right on its head. It's this concept that genius doesn't always come from a single brilliant mind, but can actually bubble up from the simple, chaotic actions of a crowd. Let's see how it all works.
Okay, so picture this with me. You're standing in a massive, empty room, and all over the floor there are hundreds of these small, really basic robots. They start to power on and move, and honestly, it's not pretty.
They're just bumping into each other, stopping and starting, changing direction for what seems like no reason at all. There's no pattern, no logic you can see. It just looks like a total mess. Nothing about this feels intelligent. At all.
But then you start to notice something. It's subtle at first. A few of the robots start forming lines. They begin clearing little obstacles out of the way. You see groups that look like they're working together on one thing, while other groups are tackling something else entirely. A really sophisticated, coordinated plan is somehow unfolding right in front of you.
And that leads to the big question, the central puzzle here. Who's conducting this whole symphony, right? There's no main computer, no person with a remote control pulling the strings, so where in the world is the intelligence actually coming from?
And that question, that gets us right to the heart of what we're talking about today. We are looking at a kind of intelligence that isn't designed from the top down. Nope, it grows, it emerges, from the bottom up.
The official term for this is emergent intelligence. Now, the really interesting part of this, the part that's kind of hard to wrap your head around, is that last phrase, none of whom are in charge. The smarts don't live inside any one robot, they exist in the space between them, in the network of all their little interactions. It's a group thing.
Now, if you're thinking this sounds like something out of a sci-fi movie, well, it's actually one of nature's oldest tricks. The blueprint for this kind of intelligence has been getting perfected for millions of years, all around us.
I mean, just think about an ant colony, right? Not a single ant has the blueprint for their massive underground city, but they build it perfectly. Or a flock of starlings making those incredible patterns in the sky. There's no lead bird choreographing that dance. It just happens.
So, how on earth does it work? Well, it all boils down to a few incredibly simple rules. You can see them here. An individual, whether it's an ant, a bird, or a robot, doesn't need the master plan. All it has to do is pay attention to its immediate neighbors, react to what's right in front of it, and make tiny little adjustments. That's it.
And this creates what scientists call the swarm paradox. It's a paradox because it just goes against our basic human instinct to look for a leader, right? To look for a plan. We're so wired to think that complex results must come from complex instructions. But here, you have these super simple local rules that somehow scale up to produce breathtakingly smart behavior on a global scale. It's wild.
So, to try and solve that paradox, researchers are now taking the swarm out of the wild and bringing it into the lab. They're using robotics to really put these principles to the test in the real world. The whole philosophy here is to kind of step back and let go of control. Instead of programming a specific answer to a problem, engineers just give the robots a simple set of rules for how to interact, and then they just let the system figure it out. And the craziest part? The best solutions are often the ones the designers never could have predicted.
Now you can see this approach is completely different from traditional AI. On the right, you've got your standard, predictable, centrally controlled system. But emergent systems, over on the left, they're unpredictable by their very nature. If something goes wrong, you can't just go in and fix one line of code, because the bug might not be in the code. It might be in the complex web of interactions itself.
But hang on a second. Here's a wild thought. What if we're looking at this all wrong? What if these so-called problems, being unpredictable, being hard to control, resisting easy fixes, what if those aren't bugs at all? What if they're actually the defining features of another incredibly complex system that we're all very familiar with?
That's right. We're talking about the human brain. The similarities between how a swarm works and how our own minds work are becoming so startling that scientists just can't ignore them anymore.
I mean, just look at this comparison. When you're talking about control, they're both decentralized. For communication, both use simple local rules. And the result? In both cases, you get something incredible, complex behavior, or even consciousness itself that just emerges from the system as a whole.
So here's the crucial idea. There is no CEO neuron in your brain that's in charge of you. Your thoughts, your memories, your awareness, your entire sense of self, it all emerges from the constant, buzzing interaction of billions of individual neurons, not a single one of which has any idea that it's a part of you.
Okay, so this isn't just some cool theory to think about. It has massive real-world implications, both for the incredible things we can build and for the really tough questions we're going to have to answer. We're already seeing swarm tech being developed for some really critical jobs. I mean, imagine swarms of tiny robots that can go into a collapsed building after an earthquake, or monitor the health of an entire coral reef, or completely reorganize a warehouse overnight. Because the system is decentralized, it's super resilient. If a few robots get taken out, the swarm just adapts and keeps going.
But all this power brings up some very heavy ethical questions, right? If a swarm of autonomous drones makes a mistake and causes harm, who's at fault? You can't blame a single robot, and the human who designed it didn't specifically program that bad decision. And think about this. How do you even begin to create laws for a technology when its key feature is that you can't ever fully predict what it's going to do next?
And finally, maybe the most chilling question of all. What happens if an emergent behavior starts to spiral out of control and we realize there's no single off switch we can flip to make it stop?
So, really, the big takeaway from all of this is a massive shift in perspective. For decades, we thought the path to true AI was just building bigger, more complicated, smarter machines. Emergent intelligence suggests we might have been looking in the wrong place the whole time. The real magic isn't in the individual part, it's in the network that connects them.
And that leaves us with one final, really provocative thought to chew on. Maybe we've been trying so hard to build intelligence, piece by piece, like it's some complicated machine, when all along it was something that was meant to grow on its own, like a forest, quietly, collectively, and without ever needing our permission.